This video is for class 9 physics, and in this video we are doing the numericals of exercise 5c, right? And the formula which we are using here is the principle of flotation, where rho s upon rho l equals to small v upon capital V. Here rho s is the density of solid, right? Rho L is the density of liquid, and we have small v is the volume submerged. In the liquid, whereas capital V is the total volume of the solid, right? So we need only this formula, right, from this section, but we should know the formulas of upthrust and densities, etc., which you have used in exercise 5a and 5b also. So let us go to the question first. So coming to the first question, which reads as: a rubber ball floats on water with its 1/3 volume outside water. So 1/3 of the volume is outside water. What is the density of rubber? So you're supposed to find the density of rubber. Obviously we need to use the formula rho s upon rho l is equal to small v upon capital V, right? But here rho l is not given, but it is mentioned water, hence I can take the density of water. A small v indirectly given, right? And the capital V is also not given. Let us understand the question first. To understand the question, we have taken a beaker, right? And in the beaker we pour some water, right? Inside the water there is a ball submerged. Such that its 1/3 part is above the surface of water. Now the remaining portion here should be inside the water, right? And I am supposed to find the remaining portion first. So as you all know, the total volume of the ball can be taken as one part of the fraction, right, the whole, minus the upper portion, that is 1/3, shall give me small volume small v, right? And that thing will solve our problem, right? So let us go to its solution. So coming to the solution of number 1, the thing which is given to us is the volume outside water. The volume outside water is 1/3, right? Since the total fraction of volume is 1, right, which I have explained, therefore the volume inside the water will be 1 minus 1/3, which will give me 2/3, which shall give me 2/3. Further solving it, we can write the principle of flotation, which is rho s upon rho l equals to small v upon capital V, and then replacing the values of rho l, which is 1000 kilogram per meter cube, which we have assumed for water, and 2/3 was the volume which is inside the water, and 1 is the total volume of the object, the ball, right? Now if I cross multiply and solve this, I am getting it to be rho s equals to 666.66 kilogram per meter cube, right, which is nearly equal to 667 kilogram per meter cube. So I hope you have understood question number. Coming to question number 2, a block of wood of mass 24 kg, right, floats on water. The volume of the wood given to us is 0.032 meter cube. find the volume of the block below the surface of water, and then the density of wood. This particular problem can be approached by two methods. Number one, either you first find the density by using the mass and the volume given, density equals to mass by volume, and then find the small v using the principle of flotation, or using the again the principle of flotation first, right? First find the volume and then find the density, right? So I am following the second approach. The first one is much easier, you can try it. I am following the second approach, right? Let us understand the concept of the question more and then go to its solution. So here we shall consider a beaker, right, a container. This particular container contains water, suppose, right? This particular container contains water. This is the surface of water here, and a wooden block is submerged in it. Okay, the question given to us is to find the volume of the submerged part which is below the surface of water, and then find the density of this particular material, that is rho s, right? So here we can approach by this method by first finding the upthrust acting on the hood, because the upthrust will give me volume submerged multiplied by the density of the liquid multiplied by the acceleration due to gravity. With the help of this particular formula I can calculate volume. Now to calculate the upthrust, as you all know, since the wooden block is floating, so this upthrust can be written as equal to the weight of the block, right? So first we find the weight, then we find the upthrust, then we shall find the volume submerged. Okay, after that we can use the formula rho s upon rho l equals to small v upon capital V. So let us go to this approach first. This is the longer method. Okay, so let us go to its solution. So coming to the solution of number 2, given the mass of the wooden block is 24 kilograms, sorry, therefore the weight of the wood will be 24 kgf, right? So volume of the wood given, that is capital V, which is given to us, is 0.032 meter cube. Since the block is floating, therefore the upthrust should be equal to the weight of the object. Now the value of the upthrust will come 24 kgf from here, right? Now further solving it, we shall get upthrust equals to V rho Lg, right? Now replacing the value of upthrust, volume submerged multiplied by the density of the liquid, that is water, multiplied by acceleration due to gravity. Now what happens is, after we cross multiply, we shall get the value of the volume to be 0.024. There is a point here, okay, 0.024 meter cube. So I hope you have understood the calculation part. This is the first part of the question. Now coming to the second part, where we need to calculate the density of the hood, right? Now to calculate the density of the hood, we have used the formula rho s upon rho l equals to small v upon capital V. Now then replacing the values of rho s, rho l, small v and capital V. Small v we just calculated, okay, capital V was given to us, right? And the density of water is also given in the bracket in the question. Now doing the normal calculation, okay, we will have the value of rho s, okay, by solving this. I think you can guess the value, it's written in the book also. Please write the answer by yourself, okay, after solving this. Okay, it will be 3 into 250. I think you can write the answer. So this is for number 2. Let us go to the next question, which is question number 3. Now coming to the next question, which is question number 3. A wooden cube of side 10 centimeter, right? So that means a cube should have all the sides equal, right? That is 10 centimeter, 10 centimeter and 10 centimeter, has a mass of 700 gram. What part of it remains above the water surface, right, while floating vertically on the water surface? So let's understand the question first. So we have a condition where again there's a container, right? In the container we have some amount of water and there is a wooden block which is floating vertically, right? The block is a cube whose all sides are equal, right? So we have this all the sides as 10 centimeter, okay, all the sides are 10 centimeter. They are asking us what portion of the block is outside the surface of water while floating. We can get this this is the total height 10 centimeter, right? So we can get this portion in terms of height also, okay, or in terms of fraction also. But as the answer is given in terms of height, that is 3 centimeter, let us find out how will this particular height will be 3 centimeter. Okay, so let us go to its solution. So now coming to the solution of number 3, given the side of the cube is 10 centimeter, so the volume of the cube will be length into breadth into height, which will be giving me 1000 centimeter cube. Now mass of the cube given to us is 700 gram, okay. So the density of the cube from these two values, that is mass and volume, we can calculate it to be 0.7 gram per centimeter cube by using the formula mass by volume, right? Now after we know its density, okay, by solving further using the formula V upon capital V equals to rho s upon rho L, okay, V upon capital V, I am using V upon capital V, is equal to the density of the wood and the density of the liquid, right, which is 1 gram per centimeter cube because it is water. Now this units gets cancelled and hence I am getting small v upon capital V as 7 upon 10, right? Now as you have seen that the 7th part out of 10, this okay, the 7th part out of 10 is inside the water. So the third part, okay, only the third part out of 10 will be outside the water, right? Because out of 10, 7 part is gone, so the third part is only left, okay. So then we can write, therefore the height above the water is 3 centimeter because the total height was 10 centimeter, if you remember. So 10 minus 7 centimeter will be equal to 3 centimeter. So this much portion is outside the surface of water. I hope you have understood the solution, right? Let us go to the next question, which is question number 4. Coming to the next question, question number 4, a piece of wax floats on brine. What fraction of its volume is immersed? Right, what fraction they are asking us? So simply they are asking us the fraction small v upon capital V, right? Here the density of wax is given, this is supposed to be the rho s, and the density of brine is also given, which is supposed to be rho L. Now I think you can guess the answer also. I think you can do it also. If you know how to do it, please pause the video and do it. Otherwise, let us go to its solution. So coming to the solution of number 4, the things given to us is are rho s, that is the density of the solid, and rho L, that is the density of the liquid. Using the formula small v upon capital V equals to rho s upon rho L, right? we can get the fraction, that is small v upon capital V. I have just replaced the value of rho s, that is 0.95, and rho L, that is 1.1, and then doing normal calculations, right, cancelling the units, removing the decimal points, etc., right, and then doing normal calculations and cancellations, I am getting fraction which is 19 upon 22, or I can represent it in the form of a decimal number, which is 0.86. so I hope this is also clear. Number 4 is also clear to you all, because since they were asking the fraction, right, so we can represent it in a decimal number or in a fraction form. So let us go to the next question, which is question number 5. So coming to the next question, which is number 5, if the density of ice is 0.9 gram per centimeter cube, so rho s is given to us, this is rho s, right, what portion of ice will remain below the surface of water in a sea? Now the sea water's density is also given, that is rho L, right. Here also we are supposed to calculate small v upon capital V, is question mark, right. So it is same as number 4. Please try to solve this by yourself, okay, please do it by yourself. Please do number 5 by yourself. It is same as number 4, right, it's same as number 4. Now let us go to the next question, which is question number 6. The question number 6 reads as, a piece of wood of uniform cross section, we can assume it to be A, and the height is 15 centimeter, floats vertically with its height 10 centimeter in water and 12 centimeter in spirit. Find the density of wood and the density of spirit also. So this question is somewhat like number 3, but it's not exactly same as number 3, so I have done this for you all, right, but here also we have to use that principle of flotation, okay. Here I think so with the help of this I can calculate capital V, right, and in its height in water is given, that means this is small v for water, this is small v for spirit, right. Let us go to its solution, okay. I think this is quite easy. I think you can do this. Coming to the solution of number 6, right, so here let the uniform cross sectional area be A, so the volume of the hood will be equal to 15 centimeter, that's the total height of the wooden block, multiplied by the area. So as you all know, volume should be equal to length into breadth into height, right. This length into breadth can also be written as area multiplied by height. Height given to us is 15, so I have written 15 multiplied by A. Now in case of water, height inside water is 10 centimeter, so the volume inside water shall be 10 centimeter multiplied by A. The volume inside water shall be 10 centimeter multiplied by A. Now therefore the volume inside water, here again I have written the same line, 10 centimeter multiplied by A, because that was this particular logo was blocking the view, right. So I can use the formula here, small v upon capital V equals to rho s upon rho L, right. Then replacing the values of small v, which is 10 centimeter into A, and the capital V was 15 centimeter into A, equals to the density of the wood, which I need to calculate, divided by the density of water, which is 1 gram per centimeter cube. Now I think you can do the cancellation, okay. After doing the cancellation, I am getting the answer of rho s as 2.3 gram per centimeter cube, 2.3 gram per centimeter cube, right. Therefore the density of wood is 0.667, this is a point here, decimal point, so 0.667 gram per centimeter cube. I can leave the answer in the fraction also. Now for the second liquid, right, height below the spirit is 12 centimeter, so the volume below the spirit will be 12 into A, right, like before. Now using the formula, right, small v upon capital V equals to rho s upon rho L, and then replacing the values of small v. Now the small v's value is 12 into A, whereas the capital V's value is 15 into A, will be equal to the density of the solid. Just now we calculated it to be 0.667 upon the density of the liquid. Now again, doing normal calculations, cancellations, etc., right, we can get the value of rho L, that is the density of the spirit, right. So I think you can solve this from here onwards. Okay, so please try to get the answer of number 6. Do the calculation part by yourself, right, and check the answer. So this was for number 6. Let us go to the next question, which is question number 7. Coming to the next question, which is question number 7, right. A wooden block floats in water with 2/3 of its volume submerged. 2/3 of its volume submerged. Calculate the density of wood. Okay, when the same block is placed on oil, 3/4 of its volume is immersed in oil. Calculate the density of oil. Okay, here we are supposed to calculate rho L. Here we are supposed to calculate rho S. Okay, there are two cases like before, like number 6. I hope you have understood the question, right. It's like question number 6. So let us solve it. Coming to the solution of number 7, given, right, I forgot to write n. Given small v upon capital V is 2/3, right, 2/3 of water. It is already inside for water, right. So not of water, it's for water. 2/3 of 2/3 for water. So using the formula of this principle of flotation, right, and then putting the values of V upon capital V equals to rho S, I need to calculate. Rho L will be 1000 kilogram per meter cube because it is water. Now again, simplifying this, cross multiplying, I am getting 667 kilogram per meter cube, right. 667 kilogram per meter cube, that's the density of that particular solid. Now for oil, again, v upon small v upon capital V will be equal to 3/4, right, and then using the principle of flotation, again replacing the values of small v, capital V, etc., and then putting the values of rho S, which we have just calculated, I need to find the value of rho L. Now for the solving it, we shall get the value of rho L as 889 kilogram per meter cube. So I am not wasting my time in the calculation part, so I hope you can do the calculations by yourself. Now let us go to the next question, which is question number 8. Please do this question, that is number 8, by yourself. Please do it by yourself, right. Please do this question by yourself. Now coming to the last question from this exercise, that is number 9. It's quite long. Please follow the question, or you can refer the book also. Weather forecasting plastic balloon of volume 15 meter cube contains hydrogen of density 0.09 kilogram per meter cube. The volume of an equipment carried by the balloon is negligible compared to its own volume. The mass of the empty balloon alone is 7.15 kilogram. The balloon is floating in air of density 1.3 kilogram per meter cube. So many things are given. So we will not write all the things given at once. So we will approach by its sub questions, right. Number 1, the mass of hydrogen in the balloon. So I am supposed to find the mass of hydrogen in the balloon. So here density of hydrogen is given and the volume of hydrogen is given. So I can calculate the mass of hydrogen by simply multiplying the volume and its density, right. Number 2, the mass of hydrogen and balloon. So mass of hydrogen and balloon. So from here we know the mass of hydrogen plus the mass of balloon is 7.15 kg. So we can add them and get the mass of hydrogen and balloon. Number 3, the total mass of hydrogen balloon and equipment. The mass of equipment is not given. It is assumed to be x kg, so it will be this plus whatever mass we have calculated here plus x, right? And number 4, the mass of air displaced by balloon. The mass of air displaced by balloon. Okay, for this I have done the calculation. Let us when we go to the solution, let us try to understand there. And at the last, the mass of the equipment, which was x. Okay, I am supposed to find its value also. Okay, let us go to its solution. So coming to the solution of number 9, the things which is given for number 1, the volume of the balloon, which is 15 meter cube, hence the volume of the hydrogen will also be 15 meter cube. Now the density of hydrogen given to us is 0.09 kilogram per meter cube. Therefore the mass of hydrogen here will be volume multiplied by density. Now volume is 15 meter cube multiplied by density 0.09 kilogram per meter cube. Now after the multiplication we are getting 1.35 kg, that is the mass of hydrogen, right? Now going to the next portion of it, that's number 2. Number 2, we are supposed to find the mass of hydrogen in balloon. The mass of hydrogen is 1.35, whereas the mass of balloon is 7.15. This was given, right? So when we add them, we are getting 8.5 kilogram. That's how we are supposed to do number 9.2. Now coming to 9.3, 9.3's question was we are supposed to find the mass of hydrogen plus the mass of balloon and plus the mass of equipment if it is x. So the required mass will be 8.5 plus x kilogram, right? This is number 3. Now number 4. Number 4 is asking us the mass of air, right? So volume of air displaced is 15 centimeter cube. Sorry, 15 meter cube. It's not centimeter. There is a mistake here. Okay, this should not be centimeter here. So it is 15 meter cube. The density of air is equal to 1.3 kilogram per meter cube, right? So we have volume here, we have density here. So mass of air will be equal to volume multiplied by the density, which is 19.5 kilogram, right? Which is 19.5 kilogram. So mass of air is 19.5 kilogram. So what will be the weight of air? It should be 19.5 kgf. Okay, we need that for number 5. In question number 5, the upthrust will be equal to 19.5 kgf, right? Now the total weight, why will be the upthrust 19.5 kgf? Because that is the mass of the weight of the air displaced, right? Now the total weight will be 8.5 plus x kg, total weight of the equipment and the balloon and hydrogen, etc. Now according to the law of flotation, we all know that the weight of the object will be equal to the upthrust acting on it, right? Now weight of the object was 8.5 plus x and the upthrust is 19.5. Now solving for x, we are getting 11 kilogram. Hence the mass of the equipment is 11 kg. I hope you have understood everything. Thank you so much.